This lecture is on finite automata to regular expression. If you are given a finite automata, how will you convert it into the equivalent regular expression? So for that you have to use this particular formula, this particular expression. So Rij of k is equal to Rij k minus 1 or Rij k minus 1 concatenated with Rkk k minus 1 clean closure concatenated with Rkj k minus 1. So if I take Rijk, this means that this represents the regular expression from state I to j by considering k number of states. K number of states in the sense the state labels will vary from 1 to k. So if you are given the finite automata, what you can or the first step is to relabel the states. So let me relabel this state as 1, start state as 1, and you can rename or relabel the remaining states as 2, 3, etc. So here you are having only 2 states. Now if you consider the start state is 1 and final state is 2. So you are expected to determine the regular expression from state, you are expected to determine the regular expression R from state 1 to 2 by considering, so what about total number of states in this finite automata? You are having 2 states, so by considering 2 states. So our aim is to determine the regular expression R12 of 2, where 2 is the total number of states and here 1 represents the start state and 2 represent the final state. So if 1 is the final state and if 1 is the start state and 3 is the final state, then you are expected to determine R13 of, and here the superscript will be the number of states in the finite automata. So you can apply this formula. So what is R12 of 2? R12 of 2 will be equal to R12 of 1, that is Rij of k minus 1, R12 of 2 minus 1, or Rik. So Rik, that is R12 of 2 minus 1, that is R12 of 1 concatenated with Rkk. So here k is 2. So R22 of 2 minus 1, that is 1, clean closure concatenated with Rkj. K is 2 and j is 2. So R22 of k minus 1, that is 1. Now we can determine R12 of 1. So what is R12 of 1? So this will be equal to, apply this formula, you will be getting R12 of k is 1 here. So k minus 1 is 0, R12 of 0 plus Rik is R11. R11 of 0 concatenated with k is 1 here. So Rkk is R11 of k minus 1 is 0, clean closure concatenated with Rkj, that is R12 of k minus 1 is 0. Now what is R12 of 0? R12 of 0 is equal to, that is the regular expression from state 1 to 2 without any intermediate state. 0 represents no intermediate state. So regular expression from state 1 to 2 without any intermediate state is actually 0, because from state 1 to 2 without any intermediate state you can move from state 1 to 2 by consuming symbol 0. So R12 of 0 is 0. Now what is R11 of 0? R11 of 0. So that is the regular expression from state 1 to 1 without any intermediate state. That is from state 1. It can remain in the same state by consuming epsilon, or without any intermediate state, it can consume 1 and reach back 1. So the regular expression R110 will be equal to epsilon or 1. Now what is R120? Okay, R120 is 0. Now substitute this one, you will be getting R120 is 0 or R110 is epsilon or 1 concatenated with R110 clean closure, that is epsilon or 1 clean closure concatenated with R120 is 0. So this will be equal to 0 or, see, epsilon or 1. This actually gives epsilon or 1 and concatenated with epsilon or 1 clean closure. You can combine these two form one clean closure. So if we consider epsilon or 1 concatenated with epsilon or 1 clean closure, the set of strings that can be generated using this regular expression is, see, from here you can take epsilon, here you can take epsilon. So epsilon is the minimal string. From here you can take 1, here you can take epsilon. So you will be getting 1. Then from here you can take 1 clean closure. In the sense you can have 1, 1, then 1, 1, 1 and so on. So this is actually 1 clean closure. So we can minimize this to obtain 1 clean closure concatenated with 0. Now again if you consider 0 or 1 clean closure 0. So what about the set of strings that can be generated using this regular expression? So the minimal string is 0. Then here if you take 0 occurrence of 1, the result is 0. That is already here. Now you can have 1, 0. You can have 1, 1, 0, etc. So this is actually equal to 1 clean closure 0. If I take 1 clean closure 0, you can have 0, 1, 0, 1, 1, 0 and so on. So this can be again reduced to 1 clean closure 0. So that is R121. Now, so you are having R121 in your hand, R121 is there, then R221. So what is R221? Apply this formula, you will be getting R22 of k minus 1, that is 0, or R21 of 0, that is Rik of 0 concatenated with Rkk. Here k is 1, so R11 of 0 clean closure concatenated with Rkj, that is R12 of 0. So this is equal to, what is R22 of 0? R22 of 0. That is the regular expression from state 2 to 2. From state 2 to 2 without any intermediate state. So from 2 without consuming anything, it can remain in the same state, or by consuming a 0 it can again remain in the same state, or by consuming 1 it can remain in the same state. So without any intermediate state we are having 3 options from state 2 to 2, without consuming anything, by consuming a 0 or by consuming a 1. So we are having R220, then R210, this is equal to, from 2 to 1 without any intermediate state, what is the regular expression? From 2 to 1 without any intermediate state, what is the regular expression? Here you are having no transition from 2 to 1. So this will be equal to null set. R110 is in our hand, then R12, that is also here. Now substitute this one. This will be equal to epsilon or 0 or 1, that is R220, R210, that is null set concatenated with R110 is epsilon or 1 clean closure concatenated with R120, that is 0. So this is equal to, if you concatenate null set to any sub expression, the result will be null set. So this will be equal to epsilon or 0 or 1 or null set. This will be equal to epsilon or 0 or 1. So you can, if you are having some regular expression or null set, that will be equal to regular expression. So we are having R2 to 1. Now we can substitute R12 and R22 in R12 of 2. So R12 of 2 is equal to, as per this equation, R12 of 2 equal to R121. R121 is 1 clean closure 0 or R121, that is again 1 clean closure 0 concatenated with R221. R221 is epsilon or 0 or 1 clean closure. R221 clean closure, that is epsilon or 0 or 1 clean closure concatenated with again R221. R221 is epsilon or 0 or 1. Now we can reduce this expression. This is equal to 1 clean closure 0 or 1 clean closure 0 concatenated with what is epsilon or 0 or 1 clean closure concatenated with epsilon or 0 or 1. So you are having epsilon or 0 or 1 clean closure concatenated with epsilon or 0 or 1. So this is equal to, see, if I take epsilon or 0 or 1, what about the strings that can be generated using this expression? So that is equal to epsilon 0 1 0 0 1 0 1 1 0 1, etc. That is any combination of strings that can be generated using zeros and ones, and this is equal to 0 or 1 clean closure. And you are actually concatenating this with epsilon or 0 or 1. So if we concatenate this with epsilon or 0 or 1, still it will be equal to epsilon, still it will be equal to 0 or 1 clean closure. In the sense, this will get reduced to 0 or 1 clean closure. Now this is equal to, so you are having 1 clean closure 0 or 1 clean closure 0 concatenated with 0 or 1 clean closure. So this can be further reduced to 1 clean closure 0 concatenated with 0 or 1 clean closure. So if you consider this particular regular expression, it can generate the sub-expression 1 clean closure 0 by considering this as epsilon, and again it can generate this sub-expression. Now verify whether this is correct or not. If you consider start state, from here it can consume 0 or more ones, that is 0 or more ones, followed by a 0, followed by any combination of zeros and ones including null string. That's it. Now consider this particular DFA. You are having two final states. So you need to determine the regular expression that accepts strings at final state 2 and that accepts strings at final state 4. So you are having the set of strings that are accepted at final state 2 or the set of strings that are accepted at final state 4. So the regular expression will be of the form R12 of 4. Since we are having 4 states, here it will be 4, and R14 of 4. So you are expected to determine this regular expression R12 of 4 or R14 of 4. This regular expression represents the set of strings that are accepted along this particular path, and this regular expression represents the set of strings that are accepted along this particular path.